Hi, this is your chemistry teacher, Miss Carden, and I'm going to be doing a lab explanation for Lab 5, Chemical Reactions, which starts on page 17 in your laboratory manual. And I have my gloves on and my goggles on, so let's get started. But let's start with part 1. This part actually has two different sections, so in the first part of part 1, you have to use the 250 milliliter beaker. Because we only have one beaker, we have to dump it out, rinse it out, and then fill the beaker back up again. So the first thing that we have to do is add 125 milliliters of water to our beaker. And this is a qualitative experiment, not quantitative, so if we don't get it right between the 100 milliliter mark and the 150 milliliter mark, we're okay. So I'm going to add water, and that's a good amount for this experiment. And I actually have my balance out because I thought we were going to have to actually measure out 2 grams of the alum, but we actually have 2 grams in this bottle, so we don't have to do any measuring with our scale. We can just pour this bottle right in here. And it does say to dissolve the alum with a plastic spoon. If you don't have a spoon, a fork is fine. We also have stirring rods that they included in the kit. You could use that as well, and there's more than one. There's 3, so you can use one of these for each one of the experiments in part 1. I'll use this plastic fork though, since I got it out. And I don't know how thorough they want us to dissolve it, but I'm going to try to dissolve it completely and see if I can do that. It says it may take a moment or 2 of stirring, so I guess they mean it takes a while. But for the sake of time, I'm going to pretend like it's completely dissolved here. And once you have it completely dissolved, you're going to add 10 milliliters of household ammonia. It's in this bottle, and it's got a green label on it. And you're going to use your graduated cylinder to measure out 10 milliliters of the ammonia. So you're going to want to drop it, this is going to be kind of tedious, until it fills all the way up to 10 milliliters. And be careful not to breathe this stuff in because you can pass out. We're back now after a moment of technical difficulties. One thing I do want to mention, before you put any chemicals into your graduated cylinder, please make sure that it doesn't have a hole at the bottom of it. So now I have 10 milliliters of my ammonia that I got from this dropper bottle, but it's actually water because all of my ammonia spilled out on the table. But just for the sake of demonstration, I'm going to pour this ammonia into our container with the water and the dissolved alum. So once you add your ammonia, you can stir it a little bit more and then record your observations. Okay? And now in order to do part 2, we have to dump out this solution into the sink and then dilute it with a lot of water. So, okay, I'm back now with the beaker that I've washed out. And for the second part of part 1, we're going to do the same thing essentially that we did in the first part. We're going to fill up the beaker with 125 milliliters of water. But instead of adding the alum, we add 4 grams. That's too much. Doesn't matter. It's quantitative or qualitative. We add 4 grams of magnesium sulfate, and then we stir it to dissolve it. So don't use the fork or whatever utensil you use in the first one because it'll contaminate this solution. So stir it until it's dissolved. It might take a minute or 2 to do that. Okay. We're going to pretend like that's completely dissolved for the sake of time. And you can take the ammonia dropper now because this is supposed to be 20 milliliters and you use 10 in this, so it wants you to put 10 in this, so whatever's left over in this bottle should be 10 milliliters. So I'm just going to very tediously drop the rest of this solution, this ammonia, into the solution. Record your observations at this time and then record it after you let it sit for 5 minutes. Okay, we've moved on to part 2 with the single displacement reactions, and you can see in table 1 on page 19 what is required in each one of the wells. And you can see a picture down below for the metals, the solids that will be in each one of the labs. So we're using, or each one of the wells. So we're using these 4, so A1, A2, A3, A4. And in A1 and A3 we need to put some powdered zinc. And it says half a scopula. I guess it doesn't really matter. Just put some in there because, again, it's qualitative. Just make sure you're not getting it into the other wells. Okay, and A2 requires aluminum as the solid. And you have to use your own aluminum. So you have to go get a piece of the aluminum about maybe like 1 or 2 centimeters squared, and ball it up into a tiny ball and then put it into A2. Okay, and then in A4 you're going to be putting like 3 or 4 pieces of copper. And you have this bag that has copper in it. It has like this thick stuff, and then it has a sheet of copper and whatever, I think that's copper wire. But then it's also got the thinner copper, and you're going to use the thinner copper for this. And because copper is so soft, you can actually cut it with a pair of scissors, not like a Crayola pair of scissors, but a relatively strong pair of scissors. And that's what I've done here. I've got 4 pieces cut so far, and just to show you, be careful to aim it down so it doesn't pop up into your eye, because it will tend to fly. So just make sure you can keep up with the pieces that you cut. So put 3 or 4 pieces of the cut copper into A4. And now you're ready to put your copper sulfate and silver nitrate into these wells as well. So in A1 and A2, you're going to be putting, let's see what it says, 25 drops of copper sulfate. So 25 drops of copper sulfate in this, and then 25 drops of copper sulfate in this. And so this, the blue solution is the copper sulfate. So 25 and then 25. And then in A3 and A4, you've got silver nitrate. Here it is. It's in this white bottle that's not clear. So 25 drops of this and this, and then 25 drops of this and that. Then you are going to record your observations in the data table that is in the Unit 5 folder in Doc Sharing. And then we can move on to Part 3. Okay, so now we have moved on to Part 3, dealing with double displacement reactions. And if you look on page 20 in your laboratory manual, on Table 2 will tell you what substances need to go in each of the wells. I do want to note several different things about this part. Firstly, if you look on page 20, there is a picture there. And I don't know why they put it under the procedure for Part 3, because that's actually what the well looks like for Part 2. But that's not what our well's going to look like, or our well plate is going to look like for Part 3, so don't let that confuse you. In Part 3, we're going to be using A1 through A6, so this top row right here. And then also, this says that our Table 2, one column's labeled solids, but we actually weren't given any solids. We were given a solution of sodium chloride, which is supposed to be one of our solids. We're given a solution of sodium hydroxide, which is, I don't think it would ever be a solid. I don't know why it's labeled a solid. And then I was also given sodium phosphate instead of phosphoric acid, and those are not the same things. So I don't know if I have phosphoric acid in some other part of my kit, but this is what was in Lab 5, and it's not the same thing as phosphoric acid. But I'm going to use the sodium phosphate anyway, and then record my observations that I see. So anything that says phosphoric acid or Na3HPO4, I'm actually going to be using sodium phosphate because that's the only thing that they gave me. So this is going to be the same thing that we've done in the past 2 labs. We're just going to take 25 drops of each substance in the solids column and put it in the wells as it specifies in the table. So A1, you see, has sodium chloride and needs 25 drops of sodium chloride. And then you see A1 also has copper sulfate. So you're going to take 10 drops of everything in the third column labeled solutions. So 10 drops of everything that's labeled solutions in the third column, but then 25 drops of everything that's in the solids column. So just to give you an example, I can, if you need me to, do 25 drops of the sodium chloride solution in 1, 2, 3, 4, 5. And then sodium chloride also goes in 4A. Okay. Then the sodium hydroxide goes into 2A and 5A. And then the phosphoric acid, or the sodium phosphate, goes into 3A and 6A. Okay. And now we need our blue copper sulfate solution. It's going to go in the first 3 wells, so A1, A2, and A3. We only have to do 10 drops of this. And then 10 drops of the silver nitrate in each of the last 3 wells, A4, A5, and A6. Okay, you can use the data tables in DocSharing to record those observations. And once you've recorded your observations, you can answer the questions that will be due for this lab. Now that we've made all of our observations and completed each part of the experiment for the chemical reactions, we can answer our questions. So let's talk about the questions and how to get full credit for these questions. Each question has more than one piece of information you have to provide in order to get full credit. If you look at question 1, it's dealing with part 2, the single displacement reactions. It wants you to list what happened in each well. And then if a chemical reaction did occur, based on the observations you made, write the balanced equation for that. So a chemical equation is the reactants on one side with an arrow and then the products on the other. And then for number 2, it's dealing with part 3, double displacement reactions. It's the same thing for question 1. You have to describe what happened in each well, including the colors that were formed, and you also have to write the balanced equation for each one of the chemical reactions that reacted. And then in part 3, you have to provide first your observations, and then you have to answer the question, is either reaction actually a synthesis reaction as labeled in the laboratory, and then you have to explain why or why not. So make sure that you include all portions of the questions that are being asked in order to get full credit for your assignment, and once you've completed it, you can put it in the laboratory Dropbox for Unit 5.